HC Verma, Wave Motion and Waves on a String, Question 12. Here is the figure from the problem. It shows a plot of transverse displacement y versus position x for a string at time t equals 0. A sinusoidal wave is passing through the string in the positive x direction with a wave speed of 20 cm per second. Let us observe the key features of this wave. Here is the full question. A traveling wave is passing through a string in the positive x direction with a wave speed of 20 cm per second. The figure shows the transverse displacement at t equals 0. Find part A, the amplitude, part B, the wavelength, part C, the wave number k, and part D, the frequency f of the wave. The key concepts for this problem. Amplitude A is the maximum transverse displacement, read directly from the graph. Wavelength lambda is the distance for one complete cycle on the graph. Wave number k relates to lambda as k equals to pi over lambda. And frequency f relates to wave speed v and lambda through the fundamental relation v equals f times lambda, so f equals v over lambda. Part A. The amplitude. From the graph, the maximum transverse displacement is 1.0 mm. So, amplitude A equals 1.0 mm. Part B. The wavelength. One full cycle on the graph spans from x equals 0 to x equals 4 cm. So wavelength lambda equals 4.0 cm. Part C. The wave number k. We use the formula k equals to pi over lambda. Substituting lambda equals 4 cm, k equals to pi over 4 which is pi over 2, approximately 1.57 or about 1.6 per centimeter. Part D. The frequency f using the fundamental relation v equals f times lambda. So f equals v over lambda. Substituting v equals 20 cm per second and lambda equals 4 cm, we get f equals 20 over 4, which is 5 Hz. Here are all the correct answers. Part A, amplitude A equals 1.0 mm. Part B, wavelength lambda equals 4.0 cm. Part C, wave number k equals 1.6 per centimeter. Part D, frequency f equals 5 Hz. Here are some important tips. Tip 1. Amplitude is always the maximum displacement from the mean position, read directly from the graph. Tip 2. For wavelength, find the distance between two consecutive points in the same phase, for example crest to crest. Tip 3. Wave number k has units of inverse length. Do not confuse it with the number of waves. K equals to pi over lambda. Tip 4. Remember the relation v equals f lambda. Given any two of wave speed v, frequency f, and wavelength lambda, you can always find the third. Like and subscribe for more HC Verma solutions at MAGPIEHUB. See you in the next video.